Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now we had started with the discussion regarding the isometric projections of the standard shapes in the previous lecture. So, and three shapes, the three basic shapes, that is square, rectangle and triangle, we had evaluated that how to draw these three shapes in three orientations onto the isometric projection. And what were these three orientations? That is the horizontal face, then the left hand vertical face and the right hand vertical face. So in the three orientations we had evaluated to draw the three basic shapes onto the isometric projections in the previous lecture. Now we are going to continue with this discussion. So let us start with the circle. How we can go about drawing the circle in the isometric projections. Now while we draw the circle in the isometric projections, we work out that the circle appears like an ellipse in the isometric projection. So here we can see we have drawn the circle in the horizontal orientation, left hand vertical face orientation and the right hand vertical face orientation. So in the you see horizontal face orientation, the solid will be moving up. That is, once we draw this ellipse or a circle over here, then the height will be coming in this direction. That is, if we are talking about a cone or a cylinder, so the upper part of the cone and cylinder will be moving like this. Similarly, for the left hand vertical face, so this is the basic shape we have drawn. We are looking at it from the left hand side, and then the length will be coming in this particular direction if I am drawing a cylinder over here. Similarly, in the right hand vertical face, I have drawn this particular circle or an ellipse facing the right hand over there. I am looking at this object from the right side, and the depth of this object, again a cylinder, it will be oriented in this orientation over there. Now we see that this circle, it is appearing like an ellipse. Now we had already discussed that the basic shapes, they are not maintained or retained in the case of isometric projection. So we'll work out that how this circle, it translates into an ellipse construction in the isometric projection. So in order to draw a circle in the isometric projections, so the first thing we need to do is that inscribe the circle within a square over there, because circle can be inscribed in a square because both the diameters are equal. So the boundary or the whatever rectangle we have tried to construct over there, it becomes a square because both the diagonals of the circle, they are going to be equal. So we have inscribed this circle, whatever the diameter is given, it may be 30, it may be 40, it may be 50 millimeter. So we know the diameter of the circle, and then first step is we are going to inscribe this circle into a square. And once we draw a square which is going to inscribe the circle, we know that one fundamental is already cleared, because in the last lecture we had seen how do we draw a square onto the isometric projections, and we had evaluated that once we draw a square in the isometric projections, it looks like a rhombus over there. Once again, all the shape of the square, it is not retained or maintained in the isometric projection. So we can see there is a longer diagonal of the rhombus and there is shorter diagonal of the rhombus. So the two diagonals of the square, when you draw it in the isometric projection, they will not be equal, whereas in the original square, the two diagonals of the square, they happen to be equal. So once you draw it onto the isometric projections, we are going to get one longer diagonal of the rhombus and one shorter diagonal of the rhombus over there. So let us see how we can work out the construction of this circle or an ellipse into the isometric projection in all these three orientations. Now let us start with the basics. So we are given that we are required to draw the isometric projections of a circle whose diameter happens to be 50 millimeters. So what we have done, we have constructed a circle having diameter equal to 50 millimeter, and then we have inscribed this into a square over there. Then before we start drawing this projection, we need to draw this isometric scale. That is, the isometric length will be located at an angle of 30 degree and the true length will be available at an angle of 40 degree. So once you draw this true scale and then you draw the perpendiculars over there, so that the isometric length corresponding to the true length can be evaluated. Now we need to draw the base. You see over here, the horizontal baseline, locus line, or the ground line we have drawn. Having drawn the ground line, now you see we are going to draw the left hand vertical face. So in order to draw the left hand vertical face, two dimensions or axes we need. One axis is, this axis is called x-axis and this axis is called y-axis. So between x-axis and the y-axis, I need to draw first of all this particular square. So once I draw square between x and y-axis, then we will see how to proceed further. So the name of the method which is used to construct this circle in the isometric projection, it is called 4 center method, right? So this is called 4 center. That is, 4 arcs will be required to draw an ellipse, and this will be perfect circular ellipse which will be able to draw. So step number 1, you see this is my x-axis, this is my y-axis. So for the time being, I don't require the z-axis, so I need only x and y-axis. Now on the x-axis, once again, this is my 50 millimeter length. So I am going to measure the isometric length corresponding to the true length of 50 millimeter, right? So once I measure this, over here I am going to mark this isometric length along the x-axis. So the AB, just check, AB length happens to be 50 millimeter. So this is the isometric length, it's not the true length. Then the height of the square will again be 50 because BC is also 50. So then I have drawn the height equal to 50 and this length along the x, this is also equal to 50. Now you join this. So these two lines, they are the isometric lines and these are the isometric axis lines over there. So the two edges of the square, that is AB and BC, they will be lying on the isometric axis, while the two lines CD and DA, they are the isometric lines which are parallel to the isometric axis over there. So CD is parallel to BA and DA is parallel to CB. Now once we have drawn this square, so we have evaluated that there are two diagonals of the square. Please check, there are two diagonals of the square and the square appears to be a rhombus over there. So we have been able to obtain square, but it looks like a rhombus over there. So in the rhombus there is one larger diagonal and there is one shorter diagonal. Now this method is called 4 center method. Now in this 4 center method, what we need to do, please see, this is the main interest to us to begin with. Okay, so to begin with, this is our main focus. So what we are going to do, we are going to find the midpoints of all the 4 edges of the square, right? So we are going to obtain the midpoint of all the 4 edges of the square, and then from the shorter diagonal, you see, from the shorter diagonal, this corner, I am going to join midpoint of this edge BC over there. From corner A, I will be drawing a construction line which will be meeting this midpoint of the edge BC of the square. The first point I have named as M1. Similarly, from here I am going to join this particular side, midpoint of this side CD over here, and this point which will be obtained, this will be called M2. Okay, so from this shorter diagonal, you see, from this shorter diagonal, one corner I have picked up, corner A. From the point A, I have joined the midpoint of BC. Similarly, from the corner A, I have joined the midpoint of CD. Now same procedure will be followed from the corner C, other end of the shorter diagonal. So from the point C, again I am going to draw the construction line which is going to be joining with the midpoint of the edge AB of this square. Okay, so name of this point is N1. Similarly, from here, from the point C, I am going to draw a construction line which will be joining the midpoint of the edge of the square, which happens to be AD over here. Now, having drawn these four, you see, construction lines, all my four centers, they have been obtained. So my first center, you see, it happens to be this one, that is the point of intersection of the longer diagonal and this particular construction line and this construction line. Okay, so this is my first center. Then this is my second center, that is from this C, I had drawn this projector. From A, I had drawn this projector, and this is my longer diagonal. So wherever these three construction lines join, one on this side, one on this side, so two centers, they have been located. Similarly, my other two center points, they are the corners of the shorter diagonal. You see, this is my shorter diagonal AC. That is why I told you that our main focus will be upon the shorter diagonal. Okay, so 2 points, that is 2 ends of the shorter diagonal A and C, they will be my next two centers over there. So 4 centers I have been able to locate. The 2 centers, they are lying at the ends of the shorter diagonal, and other 2 centers I have located over here. So let us start drawing the 4 arcs. Please check, this is my first center. So I'll keep my needle of the compass over here. I'll open the compass equal to AM1 or equal to AM2. So the radius will be the same. So AM1 and AM2 radius will be same. I'll keep my needle of the compass here. Open compass this much. Draw a perfect arc between M1 and M2. So I am going to draw a perfect arc with the help of my compass joining A with M1 to M2 over here. This is my first center. Similarly, I have moved to point C now. This is my second center. So from the second center, what I am going to do, once again, keep the needle of the compass here. Open compass equal to CN1, this is point C, and equal to CN2. So the radius will be the same. So CN1 distance is equal to CN2. So open your compass from point C. So needle will be here. This will be your pencil point. Again, using the compass, draw one perfect arc joining C with N1 and N2. So the 2 arcs for the ellipse, they have been drawn. Now the third center is this one. I told you that these are other 2 centers. Now keeping your needle of the compass here, open compass equal to C3N1 or C3M1. Okay, so keep this compass radius as this much. So once you have this much radius, so with C3 as center, now you draw arc number 3. So again, perfect arc using your compass has been obtained. Now the fourth center is this point. So using the center as C4 and radius is equal to C4M2 or C4N2. Okay, so this is my radius C4M2 or C4N2. So once again, opening this much compass, draw the fourth arc over there. So with this, we have been able to draw the perfect ellipse using 4 arcs over there. So the 4 centers, they have been located. So that is why the name of this method, which works out to how to draw the circle in case of isometric projection. So since we are using 4 centers to draw the construction of this ellipse, so that is why the name of the method goes as 4 center method. So this is the ellipse or the circle we have drawn from the left hand vertical face orientation. So let us repeat this for the other orientation, that is right hand vertical face. So in the right hand vertical face, you see I need y axis and I need z axis over there, because I am going to look from this side. So if I am going to look from this side, so these 2 axes I am going to require. One is y axis and another one is z axis. Now you see, I have shown all these 3, but this one I am not going to use as of now. So step number 1, I have already inscribed circle within a square. Scale has been, this isometric scale has been developed, and now once I measure the isometric length equal to 50 millimeter, I am going to mark it over here. I am looking from this side. So this is my 50 millimeter that I have marked onto my Z axis. Then I'll mark the 50 millimeter up from the point B, and similarly I am going to complete my square over there. So we have already learned how to draw a square. So these two lines AD and AB, they are lying on the isometric axis, and the edges CD and BC, these are the isometric lines because they happen to be parallel to the isometric axis over there. So having obtained this square which is looking like a rhombus, it appears like a rhombus, we have to join the diagonals of the rhombus, and we work out that there is one longer diagonal. Please check. This is one longer diagonal and this is the shorter diagonal. Okay, so we are mainly focused about this shorter diagonal. So we have to obtain the midpoints of all the four edges of the square. Once we obtain the midpoints of all the four edges of the square, now from the two corners, as we did earlier, from this corner draw the construction line joining the opposite midpoint over here. So this name is M1. So B1 M1 is a construction line which joins B1 with midpoint of the edge CD. Similarly, from B draw another construction line which will be joining the midpoint of the edge AD over there. Similarly, from the other corner, that is other corner which is the shorter corner, right, which is the shorter diagonal over there. Now from point D, once again you draw the construction line which will be joining the midpoint of AB over there. This is my edge AB. So this construction line is going to join the midpoint of the edge AB, and the name of this point is N2. And finally, from point D of the shorter diagonal, you draw a construction line which will be joining the midpoint of the edge BC over here at this point. And we will find that this major diagonal and these two construction lines, they are going to meet at one point. Similarly, this major diagonal and these two projector lines, they are going to join at the same point. So this is one center, this is second center, and these two are another two centers over there. That is, the corners of the minor diagonal, they work as two of the centers. So since the name of the method goes as four center, so the four centers we have identified. One center is point B, another center is point D, other two centers are these intersection points. So let us start working out the construction of the ellipse. Now from this point B, which is working as my first center point, I will open the compass equal to BM1 or BM2. So once I open this much compass, please check, I will keep the needle of the compass here. By opening this compass, I am going to join. With the help of compass, a perfect arc will be obtained, joining M2 and M1. Just see, joining M2 and M1, a perfect arc has been achieved. Now, my second point is second point or the corner of my minor diagonal, which is BD. So from point D, which is my second center point, I will open the compass equal to DN1 and DN2. Open compass equal to DN1 or DN2. And this is the needle point, open compass this much, draw a curve, which is again curves drawn through your compass. So this is again a perfect arc. So again a perfect arc has been achieved. Then center 3 is this one. So from C3, open the compass equal to C3N1 or C3M1 and draw the third arc. So with this as center, this as the radius, C3M1 or C3N1. Draw the third arc over here. And this is my fourth center. So from this C4 as center, radius equal to C4M2 or C4N2. Right? So draw the fourth arc over there. So this completes the construction of an ellipse. So basically it's not an ellipse, it is the circle which is appearing like an ellipse in the isometric projection. So this was the second orientation. Now let's draw the circle in the third orientation. So in the third orientation, you see x-axis and the z-axis will be required. We don't need the y-axis. Okay, so we are going to draw only x and y. So no z-axis has been drawn. So once again, this is 50 millimeter. This is again 50 millimeter. Just check. This is 50. So we have completed the construction of a square in the isometric projection, which appears to be a rhombus over there. Now this is a rhombus in which there is a major diagonal, there is a minor diagonal. So we are focusing upon minor diagonal. So this is our main focus. Now once again, we are going to obtain the center points of all the four edges over there. So the center points, they have been obtained. Now from the minor diagonal, we are going to draw two projectors onto the midpoints of the opposite edges over there. So opposite to corner B, my two edges, they are CD and DA. So these two projector lines or the construction lines, they have been joined. So the names of these points, they are M1 and M2. Similarly, from the other corner of the minor diagonal D, point D, draw the construction lines which will be joining the opposite side midpoints over there. These are the opposite sides. So the midpoints of these two opposite sides, they have been joined. Now once again, four centers, they have been located. Center 1, center 2, center 3 and center 4. So let us start working on the ellipse. So here you see, first center point is this, that is first point of the minor diagonal. Now from C1, open compass equal to C1 M1 or C2 M2 and draw an arc using the compass over here. Similarly, this is my second center. So my radius will be this one, D and N2 and D and N1. So with this as radius, my needle point of the compass will be lying at point D, and then this is my center 2, and then once you open this much compass, you draw the perfect arc using the compass over there. Now my third center lies here, open compass equal to C3N2 or C3M2. C3N2 or C3M2. Draw the third arc over there. And finally, this is your fourth center, and using C4M1 or C4N1. So these are going to be the radii which are equal. Draw the fourth arc. So this way, a perfect ellipse can be drawn in three orientations, but it is not an ellipse basically. We have managed to draw the circle in the isometric projections over there. Now the next basic shape that we need to draw in the isometric projections, this is a pentagon. Now we can check. First of all, we need to draw the exact pentagon using the geometric construction, and whatever is the edge of the pentagon, we have to draw the pentagon using that dimension of the edge. Okay, so the true shape, actual pentagon has to be drawn using the normal geometric construction over there. So we obtain the 5 points, 1, 2, 3, 4 and 5. And once we have drawn this pentagon in true shape without bothering about the isometric projections, now the next step is, because we have already discussed, because this angle was 72 degree external angle in case of a pentagon, even this angle was 72 degree, even this angle is 72 degree. But we have already discussed that the angles and the shapes, they are not preserved in the isometric projection. So we cannot transfer all these points by marking the angles in the isometric projection. So how we can do it? First of all, we are going to make a simple geometric construction of a pentagon as usual. Forget about we have to draw the isometric projection. Now having drawn this construction of the pentagon, now we are going to mark the points 1, 2, 3, 4 and 5. And finally, once this construction is over, we need to inscribe this pentagon into a rectangle. Now this will not be a square. A pentagon can be inscribed into a rectangle over there. Okay, so this dimension AB will be the bigger dimension of this rectangle, and BC will be the shorter dimension of this pentagon over there. Okay, so if we talk about this rectangle, so for this rectangle, AB will be giving us the longer dimension of the rectangle, and BC edge, this is going to give us the larger edge of this rectangle. So what we are going to do, please check. In the three orientations, you see we have to draw this pentagon shape in the isometric projections, but everywhere you can see that we have inscribed this into a rectangle. So what we can do, we have already known by now through the previous lecture discussion that how to draw a rectangle in case of the isometric projection. So once we draw this rectangle, we are not bothered about how to draw a pentagon. First of all, we should start with the construction of the pentagon through the construction of a rectangle in the isometric projection. Once I draw this, you see a rectangular lamina over here, a rectangular projection we make, then using the rectilinear distances, I can mark these points 1, 2, 3, 4 and 5 within this isometric rectangle which has already been obtained in the isometric projection. So I repeat once again, first of all we will be drawing this rectangle in the isometric projection. After you draw this rectangle, then what we are going to do, I am going to measure this distance, you see A to 1 and 2 to B. So these distances I will be marking from these two ends, A to 1, 2 to B, right? So this distances I mark, I automatically get these 2 points. And please make sure all the distances which are marked over here, they will all be isometric lengths only. True lengths are not to be marked over here. So now you see, once I measure A1 and then I measure 1, 2 or I measure 2B, points 1 and 2 will be located along this isometric length AB. Similarly, corresponding to the edge BC, please check, corresponding to the edge BC, now I am going to measure distance of B3 in the true length, and that distance will be worked out in the isometric length. So that distance I am going to mark over here and over here. So points 3 and 5, they will automatically be located. Similarly, between this edge, that is starting from C, you move on to D, measure this length C to 4 or D to 4. So all the lengths are to be measured in isometric length, not in the true length. Here we will be measuring true lengths and then converting them into the isometric lengths while we are going to go for the isometric projection. So we are going to measure the C4 or D4. So point 4 will be located. So just see how easily using the construction of the rectangle and making rectilinear distances over there by measuring the rectilinear distances A1, 2, B, B3, A5 and 4, C4 over there. Very easily we are able to evaluate all these points. But one thing we must remember, once we draw this pentagon shape in the isometric projection, there is only one line, one edge, 1, 2, which happens to lie on the isometric axis. So this is my isometric line, whereas the edges 2, 3, 3, 4, 4, 5 and 5, 1, they are neither parallel to z-axis, they are neither parallel to y-axis, or they are not parallel to your x-axis. So these 4 edges of the pentagon, we call them non-isometric line, because these are inclined at a certain angle to your x-axis, y-axis or the z-axis. So in this figure, there is only one line which is the isometric line. Other lines, they have been obtained by using the principles of the rectilinear transfer of distances over there. So since the edges 2, 3, 3, 4, 4, 5 and 5, 1, they are inclined to x-axis, y-axis and z-axis. So these are non-isometric line. Okay. So let us start working out the construction of the pentagon shape in the isometric projections in 3 orientation. So first orientation I am going to talk about is horizontal face. So in the horizontal face I am going to use x-axis and z-axis over there. So please see, this is my x-axis, this is my z-axis. Now on this side I am going to draw, please check, A to B. So A to B is, I have measured this length as x. Please check, once I make the construction of a true pentagon, I have inscribed this into a rectangle, and the characteristic of this rectangle is that X is the longer edge, so AB is the longer edge and BC is the shorter edge of this rectangle. So please see, I have marked AB as a longer edge and BC, it is my shorter edge. So A, B, C, D points I have located. So I have been able to construct a rectangle in the isometric projections. So having worked out this rectangle, and please remember these distances, that is AB and BC, they are not equal to true lengths of X and Y. They are equal to true isometric lengths of X and Y. So whatever isometric to true length of X is worked out, I am going to evaluate isometric length of X. Similarly, whatever true length of Y is worked out, I will be working out the isometric length corresponding to Y. So these are the isometric lengths that we are talking about. Okay. So having marked these, you see 4 points of the rectangle A, B, C, D. Now I need to measure the rectilinear distances. So this is my point A. So from A, in the true geometric construction, I will be measuring this distance A1. So whatever distance is measured in true construction, so once again the isometric projection length will be worked out. So from A, I will be marking the point 1 over here. So please see, I will be marking point 1 through A, and similarly through B, I measure the distance of point 2. So this true length and this is my isometric length. So I am going to mark distances of point 2 from B and distance of point 1 from the corner A of this rectangle. So the 2 points of the pentagon have been evaluated, and besides this, you see, I have even evaluated the axis point of this, because we are going to need this while we go for the construction of the solids. So from every corner, you see, I have drawn the perpendicular bisector of the opposite edge. So wherever 5 bisectors they are going to meet, the axis point will be located. But once again, this axis cannot be transferred here directly. So how this I have transferred? I have measured the distance of point E along AB. Please check. I have measured the distance of point E from A as I move along AB. So this distance I have measured. So please check. This distance I have marked. So the first half of the axis line has been drawn. Similarly, from B to C, please check. From B to C, as you are moving, I have measured this length. Again, rectilinear distance has been marked over here. So this is my rectilinear distance. This is geometric construction true length. Isometric distance has to be evaluated. So from B, point F will be evaluated. So once you evaluate E and F, so this gives me the center point or the axis point for this pentagon. Then as I am moving from B to C, this was my point F, but my point 3 lies here. So this is only the axis point, point F. But my point 3 lies slightly above this point F. So from point B, measure the distance of point 3 over here. So from point B, I have measured the distance of point B, point 3, and then this gives me the third point of this pentagon surface. The next point is point number 5 over here. So point number 5 will be located, you see, once I measure the distance of A5, as I am going to move along AD, it lies on the edge. Please check AD. On the edge AD, I am moving from A to D. I am going to measure this distance A5. So I have measured the distance A5. I have marked a point over here. This gives me 0.5. And finally, from C, as you move towards D, from C as you move towards D, mark this length 4C over here, C to 4. So this gives me my point number 4. So all the 5 points, check, have been located. Now once I join them, I am going to get the construction of a pentagon surface in the horizontal face. Now you see here I have marked the straight edge over here. I could have marked the straight edge over here also. Then the shape of the pentagon would have changed. So let me do it again. So quickly I'll go through this. This is my x-axis, this is my z-axis. Now earlier I had located AB over here. Now if I locate my AB over here, now once again A to 1, B to 2 distance I will be marking, and then this is my axis point. So measure A to E and measure A to B to F. So once you measure, you see, you measure A to E and you measure B to F or A to F. So this point axis will be located. Now once you locate this axis, next point is from A. Please check, from A I have to measure distance of 1, isometric. So once again this isometric distance will be located. So point 1 will be created. From B I measure this distance. So please check, B2, that is second point of the pentagon, has been located. Then third point, from B to C, as you move along B to C, you will find point 3 will be located slightly above the axis. Point 3, it will be located slightly above the axis. So I am going to measure this distance B to 3 as you move from B to C. So third point has been located. Then from point A, please check, from point A, as you move towards point D, measure this rectilinear distance A5. So mark this point along AD. Please see, I have marked this point along AD. So this gives me 0.5. And finally, as I am going to move from C towards D, as I am moving from C towards D, this point or the length of this distance gives me the location of point number 4. So you see point 4 has been located. Now all the 5 points of the pentagon, they have been located, so I can join them easily. So this completes the construction. So two constructions of the pentagon in the horizontal face we have discussed. One is when you have edge 1, 2 located on the other side, and then when you have edge 1, 2 facing the observer over there. This is away from the observer, this is towards the observer. So two constructions we have completed. Now let us work out the third construction, left hand vertical face. So in the left hand vertical face I am looking from this side. So if I am looking from this side, x-axis and y-axis will be required. I don't need z-axis over here. Now please check, my longer dimension x, it has been located. This is once again, it's not a true length, it is isometric length of x. Then I draw the vertical length, it is y. This is my y vertical length. So y vertical length means this is the isometric distance corresponding to the true length of y. Okay, so this is my y distance. It's not true length. Both of all the distances marked over here, they will all be isometric lengths over there. Now let us mark the points A, B, C, D. And once I have marked these points, so I know 1 will lie here, 2 will lie here, 3 will lie here, 4 will lie here, and 5 will lie here. So I am going to measure these distances rectilinearly, and I will be able to transfer all these 5 points into this rectangle which I have obtained. So step number 1, the center point has been located. So measure the distance between A and E and A and F. You see, A and E, and this is my F point. So measure distance between AF or BF. Okay, so this gives me the center point. So once I obtain the center point, now next I need to locate all the 5 points. So please check, distance of A and 1 gives me 0.1. Distance of B and 2 over here, this gives me 0.2. So A1 distance isometric and 2B distance isometric gives me the first 2 points of this pentagon. Then next one, 0.3 and 5. So please see, 0.3, you move along BC, measure this distance over here, mark the isometric distance. From A to D, measure this distance in true length, evaluate the isometric length, 0.5 will be located. Measure this distance true length 4 to C, measure the isometric length, and then mark it over here. So all the 5 points, they can be located, and once you evaluate 5 points, join them. So this gives you the construction of the standard pentagon shape on the left hand vertical face over there. So same procedure we will be repeating on the right hand face. So on the right hand face, which axis I will be requiring? Z axis and Y axis over here. I need Z axis and I need the Y axis. So I have marked the longer edge over here of the rectangle, that is, this is the longer edge. So longer edge of the pentagon I have shown over here, and the vertical edge will be the Y, the dimension of Y. Once you reduce it 18% using the isometric scale. So Y has been located, X has been plotted over here. Just see, this is the vertical length, is length Y corresponding to this construction of the rectangle. So the rectangle construction has been completed, and then you mark all the points. So all the 4 points of the rectangle, they have been appropriately marked, and then using the distance, please check A to E and A to F. Using these two distances, AE, AF or BF, right? So I mark these points A to E and B to F. So the center point of this pentagonal shape has been located over here, right? Next, we are going to measure the distances once again, A1, B2, B3 and C4 and A5. So all these five points will be located using rectilinear distances. So please check A to 1, this has been located. B to 2, this distance has been worked out. Then B to 3 and A to 5. Please check B to 3, A to 5. Isometric distances, they have been evaluated and marked over here. And finally C to 4. We are going to mark this distance onto this rectangle edge CD. So point 4 will be located. So all the 5 points, they have been worked out, and we are able to obtain a hexagonal face which is facing the right hand side. So we call it right hand vertical face for the pentagon. And one thing you should not forget, that in this pentagonal construction, only one edge, that is corresponding to the edge 1, 2, this is the isometric line, while the rest of the 4 edges 2, 3, 3, 4, 4, 5 and 5, 1, they have been located by using the rectilinear distances, and these are the edges which happen to be inclined to all the 3 axes, that is x-axis, y-axis and z-axis. So these 4 edges, that is 2, 3, 3, 4, 4, 5 and 5, 1, they are called non-isometric line, whereas there is only one isometric line in this construction of the pentagonal shape in the isometric projections over there. And another thing we need to remember, that the angles, they have not been preserved over here. So this shape will be slightly distorted one, but this is the actual construction of the pentagonal shape as it is viewed in the isometric projection. Now the last shape that we want to discuss today is regarding hexagonal shape. So how do we draw the hexagonal shape onto the isometric projection? So once again, 3 orientations we are going to discuss: horizontal face, left hand face and the right hand vertical face. But the procedure will remain identical to that of a pentagon construction. That is, to begin with, forget about that we are going to draw the construction of the isometric projection of the hexagon. We need to have the true geometric construction of a hexagon to be completed to begin with. So whatever is the edge length given to us, so corresponding to the edge length, I am going to make a construction of the hexagon over here. So once I complete this hexagonal geometric construction to true length, then I am going to inscribe this hexagon into a rectangle over here. And the characteristic of this rectangle will be, once again, AB will be my longer edge and BC will be my shorter edge. You can see AB is going to be always my longer edge and BC will be a shorter edge, even though difference will not be much, but it will be different. So AB will always be bigger and BC will always be shorter than AB. Now, having obtained this particular hexagon inscribed into a rectangular figure over here. So once again, the same procedure we are going to follow irrespective of whichever face we are going to draw. So the two dimensions of the rectangle will be drawn to begin with. Please check. Two dimension means longer dimension AB and the shorter dimension, that is dimension Y, that is BC. So this dimension AB we are going to call as X and the shorter dimension BC we are going to call as Y. So once we draw this rectangle, so all the 4 points of the rectangle we are going to mark, okay, in every figure. And once we mark these points, so once again, A to 1, B to 2, C to 4 and D to 5. Even though these are, you see, 4 different points, but the distance of A1, 2B, 4C and D5, they will all be equal. So what we need to do, I'll be measuring only one distance over here and I can mark 4 points onto this rectangle over there so that the 4 corners of the hexagon can be located. Similarly, I will be measuring this vertical length B3 and it will be equal to the vertical length A6 over here. Okay, so only 2 lengths I need to measure and the construction of the hexagon will be completed. And another thing we need to remember here, unlike pentagon, there are 2 edges. You can see 2 edge lies on the isometric axis and this is parallel to the isometric axis. So these 2 lines or the edges, they are isometric lines over there, whereas these 4 edges 2, 3, 3, 4, 5, 6 and 6, 1, these are non-isometric lines. Okay, so now let us see how do we go about having the construction of hexagon completed onto the isometric projection. So step number 1, I will be making a geometric construction for a hexagon. Once I complete this, I will be marking all the points 1, 2, 3, 4, 5, 6, and then once I obtain this hexagon, next thing is I'll find out the center point. And another thing which I need to do, all these constructions, they will be made based upon the given edge length, whatever is the edge length of this particular hexagon. So based upon this edge length, the given construction is made. Once you make this construction, now inscribe this hexagon into a rectangle. Inscribe this hexagon into a rectangle. So AB will be your longer edge of the rectangle, BC will be the shorter edge of the rectangle. And then once all the measurements have been made, now these measurements have to be converted to the isometric length. So from the true length, you have to measure the isometric length, evaluate the isometric length, and all the dimensions which will be marked in the isometric projections, they will be corresponding to the isometric length corresponding to the true length which has been evaluated from this true geometric construction over there. Now the horizontal face I am starting with. So which axis I will be needing? Obviously x axis and z axis I will be needing. So this is going to be my longer edge, that is dimension x over here. Please see, this is my longer edge and this is my shorter edge. Okay, this is my edge y over here, BC. So my AB will lie here, my BC edge will be lying here. So let me mark all these points. So a rectangle has been completed. So these all the lines of this particular rectangle, they are all isometric lines. Now having obtained this rectangle, now the next thing is I have marked the distances over here. This is my longer edge x, that is AB. This is my shorter edge which is equal to BC or AD. Now I am going to mark all the 6 points over here, 6 points of the hexagon. So please see, I have marked these 2 first points, that is 3 and 6. So 3 and 6 will be obtained as I have already explained. You move from B towards C and measure this distance equal to B3. Similarly, you start moving from point A towards point D and measure the distance of point 6 and evaluate the isometric lengths A to 6 and B to 3. And mind you, both of them, they will be equal. B3 will be equal to A6. And next, you measure A1, 2B, C4 and D5. Even if you measure it separately, you are going to get the same length over there. So A1 will be equal to 2B, will be equal to C4, will be equal to 5D. The moment I work out this particular distance, I can mark A1, B2, C4 and 5D. So I am able to obtain all the 6 points of this construction. And in this construction, you see, once you make this construction, one thing we have decided that the longer edge was over here. So longer edge was lying here, shorter edge was lying here. So here we are assuming that this edge of the hexagon, this is lying parallel to the VP. If we are given that this edge happens to be perpendicular to VP, what we have to do? We have to draw longer edge over here and shorter edge we have to draw over here. So let us make that construction as well. So here we have the other construction, similar one, but just a change. Here we had taken longer edge over here, shorter edge was lying here. So if the longer edge is containing this edge 1, 2 of a hexagon, so we will find that this is parallel to VP. So one edge of the hexagon is parallel to VP. If one edge is perpendicular to VP, then on this side I am going to mark my longer edge. Please check. This is my longer edge X. So longer edge X has been marked here. Shorter edge Y has been marked here. Once we have marked these edges, now A, B, C, D. The moment I mark longer edge AB over here, so I understand point 1 will be lying here, 2 will be lying here, 3, 4, 5 and 6 points will lie here. So let us start marking out these points. So once again, we have measured the distance of B3 and A6. Please see, measure the distance B3 and A6, both of them they are equal. Transfer it onto the isometric length, work out the isometric length over here. So the 2 points 3 and 6 they have been located. Next, you measure this distance A1 equal to 2B equal to C4 equal to D5. So only one length I need to measure, work out the equivalent isometric length and make 4 points over here. So first arc will give me point 1, second arc from B will give me point 2, third arc from C will give me point 4 and fourth arc from point D, this will give me point 5. So once again all the 6 points they have been located, and only difference is here this edge is perpendicular to VP, here this edge happens to be parallel to VP. Right, now the access points they have been worked out, that is join these two corners, join the midpoint of AB and CD over here. So this gives me one axis line, this gives me the second axis line. So please see, point E corresponds to midpoint of AB, whereas this point F, it coincides with 3 and 6 over here. So point F coincides with 3 and 6 over here. So this way the construction of the hexagon shape in the isometric projections in the horizontal face orientation has been completed. Next, let's work out the another orientation. The another orientation is left hand vertical face. So in the left hand vertical face, I am looking from this side. So I need only the x-axis and the y-axis. So I don't need z-axis as of now. So on the x-axis, the longer edge has been developed, and on the y-axis, the y edge, that is the edge BC length has been marked over here. So AB length has been marked along x-axis, and along the y-axis, length equivalent to BC, that is y, has been marked. So the 4 points ABCD they have been marked for this outer rectangle which we had drawn, which was covering this particular hexagon. Okay, now let us mark all the 6 points of the hexagon. So from B we have marked the distance 3, from it is same distance will be from A to 6. So we get 2 points 3 and 6 over here. Similarly, A1 distance I measure. So accordingly A1 is equal to B2 is equal to C4 equal to D5. So I have obtained the remaining 4 points of the hexagon. Now once again we are able to join all these points, and this is the left hand facing, you see, shape, the hexagonal shape we have been able to obtain. And let's work out the axis. You join these two diagonals and you join this axis line and this, they will all be coinciding at the same point. So this confirms that the construction has been made appropriately over there. Now the last one for today, we are going to evaluate right hand vertical face construction of the hexagonal shape. So in order to obtain right hand, I am looking from this side. So the longer dimension I will be putting up along the z direction. So the longer direction will be AB, distance x. So it has been marked along the z axis. Now along the y axis, the shorter dimension, that is y, or equal to BC, it has been marked over there. So both these distances of x and y, they happen to be the isometric length. So all the distances which will be marked here, they will be isometric length. So we are going to measure true distances from this geometric construction, convert all of these distances into isometric lengths and mark them over here. So once I have shown x and y, I will be marking all the 4 points of the rectangle A, B, C and D. And then once again, similar to the previous one, we have marked the axis point O, that is A to E distance, and A to E distance, and A to F or B to F or B to 3 or A to 6. They are all the same. So A to 3, this can be B to 3, this can be A to F over there, right? So let's mark the points, measure the distance A1. So 4 arcs you need to draw from A, B, C, D, 4 points will be located. Measure the distance B3, point 3 will be located. Then again A1 is equal to C4. Similarly A1 is equal to D5, and similarly B3, it is equal to A6 over here. So all the 6 points, they have been evaluated. So this is the construction of hexagon shape in the isometric projections, as you are going to look at this shape from the right hand side. So if I have to draw a hexagonal prism, I will be extending the depth of the prism over here. So whatever is the length given over here, depth given over here, so same depth I will be projecting along this particular side. So then this x-axis will be used over there. So this was the construction of the basic shapes which we need to draw in the case of isometric projections, and all these basic shapes, they will form the foundation while we are going in for the discussion of constructing various types of pentagons, various types of hexagonals, prisms and pyramids, that are the solids in the isometric projection. So all types of pentagonal, hexagonal, square or rectangular prisms and pyramids we are going to evaluate. So all these things, they will require the basic knowledge about construction of the basic shapes over there. So this is all for today. So we are going to continue with the construction of different types of solids in the isometric projections in our coming lectures over there. So thank you very much. Thanks a lot. Thank you.